am Filomeno Martina, one of the founders of WAAM3D Limited and currently is Chief Executive Officer. At WAAM3D, we help companies implementing large-scale metal 3D printing. In particular, we focus on wire as feedstock and electric arcs as the heat source. And we are very well known, as you can see, for the size of parts that we can make, which are some of the biggest in the world in quite a lot of interesting high-performance alloys. When a customer comes to us with an idea, we start a very thorough and robust process of assessment, which is based on the financial case, the technical case, and also the environmental case. Often we look at parts that are machined from forgings or very large blocks of metals, which are inherently quite wasteful. And in fact, I like to describe WAAM as a technology that can help companies reduce waste across the board. So we can think about overproduction, inventory keeping, and material waste associated with the removal of swarf. So in terms of the sustainability, certainly by reducing the amount of material that we need, we can improve the environmental performances dramatically. We've looked at plenty of case studies where sometimes by reducing mass by 50%, we can reduce emitted CO2 and consume energy by the same amount. And that's, of course, very welcome, especially given today's focus on the treble bottom line and the ESG agenda that we all care so much about. Through the use of additive technology, we can also release the application of repair, which is very utilized and very demanded in sectors where we've got high value assets that would be otherwise scrapped. So we can extend their useful life, we can make them good again, and of course we can save companies money, but we can also improve the business case from the environmental standpoint dramatically. And then also, because we can play with the chemistry of the parts and with the in-process hybridization through, for example, forging, we can tailor the mechanical properties in various parts of the same geometry, reducing mass even further. Sustainability is shaping our business every day. There is cases in which the business case and the environmental case go hand in hand, and proving one means also proving the others. But historically, we saw some reticence, let's say, in exploring some applications where maybe the financial case wasn't too strong. And now we can quantify the environmental benefit associated with those applications. And because of the emphasis on ESG and sustainability agenda, those cases, even if they're not, let's say, exceptional from the financial standpoint, they do very well from the environmental one. And so they are back at the foreground of our agenda very, very much. I'd like to show you an example of a fuel tank. Actually, it's a water tank made in titanium 64 for space exploration. And the reason why I would like to show this example is that it serves very well in terms of the business case and the material savings I've discussed before. So the tank you see behind me is made in a very nice alloy, high performance alloy, which is the titanium 64, 6 aluminum, 4% vanadium, is the bread and butter of the aerospace industry because of the high strength to weight ratio. Now, traditionally, those kind of parts are machined out of very rough forging or solid billets, which means a lot of waste. You have to spend a lot of money in procuring the material and a lot of money to machine it away. What we've done with WAAM instead is to first of all consolidate the part into one big assembly. So we've got the bottom, which is the wire conduit, the main dome and the main cylinders, which are built as one. And then by making the parts using additive manufacturing, we can save about 200 kilograms of titanium on a part-by-part basis, which is an incredibly meaningful quantity, which of course has a dramatic repercussion on the cost side of things. I think we've estimated 60% reduction in cost, but also the environmental performance of the part made by WAAM is about half of the environmental performance of the same part made traditionally, and it's one of my favorite cases for exploitation of WAAM today. The titanium tank I've shown you before was made with a WAAM variant called PTA, which is a plasma transfer duct. This is a landing ring for oil and gas application, which we have made with a new process of ours called CWMIG, which stands for cold wire MIG. Why is this interesting? Because with CWMIG we can quintuple, we can make the build rate 5 times faster than other processes. And what that means is that in terms of the energy that we use, in terms of the gas that we use, in terms of the maintenance intervals and the consumables, not only is a much faster process, it's also a much better process. So we require less resources, which again, going back to the point of how we try and think in sustainable terms every day, really helps the company moving in a direction further.